We're doing 5.7. 5.7 says that we have to solve for x prime of t equals a x of t. Now, before we begin to solve for x prime, what I suggest we do is go through and we find the Euclidean values, the eigenvalues, because that's really going to help you out throughout this entire problem. So, in order to find the eigenvalues, we're going to set up this formula. The determinant a minus lambda I equals 0. Solving this is going to help us find our eigenvalues. So we're going to go ahead and plug in. We got our A matrix minus lambda 0, 0, lambda. Now, once we have that, we're going to come over here and it's going to correspond to 2 minus lambda, 3, negative 1, and negative 2 minus lambda. Now, from this matrix, we'll be able to solve for our eigenvalues. And the way we're going to do that is we're going to take 2 minus lambda equals 2 minus lambda minus 3 equals 0. And after going through, we'll get lambda value of negative 1. Now, we're going to go ahead and do the same thing with our second eigenvalue. Our second eigenvalue is going to correspond to 2 minus lambda minus 1 equals 0. And our second eigenvalue is negative 3. So now that we have our eigenvalues, we need to go and figure out what our eigenvectors are. Now, finding our eigenvectors is similar to finding our eigenvalues. Only thing is we have a different formula. The formula for this one will be a minus lambda I times x equals 0. So all we need to do is plug in our a, which is 2, 3, negative 1, negative 2, minus our first lambda value, which is negative 1, 0, 0, negative 1. So we're going to now we need to go through and we need to solve for x. So in doing so, we're going to take 2 minus negative 1, which is 2 plus 1. So it's going to give us a corresponding matrix of 3, 3, negative 1, negative 1. Now once we get this corresponding matrix, we'll reduce it and we'll achieve a matrix of 1, 0, 1, 0. So then we just need to solve for x. So x1 equals x2 and x2 equals 0, giving us our first eigenvector of 1, 0. Alright, so now that we have this, we need to do the same thing, plugging in this lambda value for our lambda. So we're just going to go ahead and take these out, plug in negative 3, negative 3. So that's going to change this. That's going to give us 5, negative 1, 3, and positive 1. Now when we row reduce that, this is going to change slightly, giving us 1, 0, 0, 1, which is going to help us achieve x of 1, which equals 0, and x of 2, which equals 1, giving us x equals 0, 1. Now that we have our eigenvalues and our eigenvectors, we can proceed to solve for x prime, because remember, that's what the original problem is. The original problem was asking us to solve for x prime. So in order to solve for x prime, we need to set up I move over here to space. This x prime t x sub 1 prime of t, excuse me, I'll show you what's up with that. Equals a 2, 3, -1, -2, and x 1, 2, 3. So from there, we're going to get x 1 prime t x 2 prime t equals negative x and -3. Once we have that, we need to go ahead and negative 3x. Alright, so after we do that, we need to go ahead and solve for x prime. And the way we do that is we just bring this down. x1, 2, t equals c